Okay, today we're going to do 13, 14 college algebra, and the section that we're going to work on for today. On your syllabi it says 2.2 for circles, and that is not correct. It should be 2.3, so make that correction. And again, 2.3 notes, and the notes deal with different topics, and some of it might be circles and different techniques. Okay. Alright, let's just go through a couple of examples to help you out, and you can follow along. It's an example that's posted in Blackboard. Example 1 for 2.3 is asking, how do you complete the square? Okay, and then this is the expression they give us. They give us t squared plus 22t plus something, and it's the third term that we're trying to figure out. So here are the steps that we need to take. Here are the steps that you need to take. The first step is take half of what will be the middle term, this is what will be the middle term right here. So 1/2 of means multiply, so 1/2 of 22 is 11. And then the second step that you do in completing the square is square that value. And so that means we're taking 11 and we're squaring 11. What does it mean to square again? That means we're saying 11 times 11, and that gives us a value of 121. So what is that telling us? For completing the square, taking half of 22 and squaring it means we're completing the square by putting 121 as the third term. Okay. A second example that they have us do is shown on your sheet. Example 2 says, for instructions, solve the quadratic using the square root property. Let's see what that entails. Okay. Well, if this is the equation that we're given, if we're supposed to solve for x, x is stuck inside that square. So we're going to use the square root property. How do you undo a square? You undo a square by taking the square root of both sides. But now in taking the square root of both sides, you're going to have a positive and a negative possibility here. So the square root of 36, you can take the square root of 36. That's going to give you a plus or minus 6. And the square root of a square means all that's left on that right hand side is x plus 3. Have we completely solved for x yet? Not quite. So the first step that we did was what? Take the square root of both sides. Okay. And then the second thing that we need to do, with this is now solve for x. So what does that mean? Well, it says that x plus 3 would equal 6, and x plus 3 would equal -6. And so if you solve, then we're subtracting 3 here. You're getting an x value that's equal to 3. And once again, you're solving by moving this 3 here. So you're getting an x value that's equal to -9. Okay. So what does that tell you our solution would be? They use these little solution braces, and they're already on there. So you'll have a 3 and -9 inside those solution braces. Okay, let's do another example. Okay. Example 3. Example 3 has a statement with a missing blank. It says for a circle, comma, something is the distance. From the center to any point on the circle. So, what is the distance? What is the distance? Huh? The radius is that distance from the center to any point on a circle. Okay. Now before we go much further, we're also going to need some formulas. Let's look at some formulas. Here are some circle formulas that you will need. One is referred to as the standard form. And the standard form looks like this: x minus h squared plus y minus k squared equals r squared, where h and k represent the center point, and r is the radius. Okay. The second form is called general form, and general form comes from standard form. If you were to go ahead and square the x minus h and add to it the square of the y minus k and then subtract the r squared, you would get this. You would get an x squared term plus a y squared term plus an ax term plus a by term plus a c, and the right hand side would be equal to 0. Okay. So now that we have the two forms, let's look at a couple more examples. Example 4 is asking us, is this true or false? And what they're asking us, if it's true or false, is the radius of the circle in this equation. Which is described as x squared plus y squared equals 9 is 3. So what they're asking us, the radius of this x squared plus y squared equals 9 is 3. Is this true or is this false? Well, let's look at the solution. So if our standard formula, our standard form says x minus h squared plus y minus k squared equals r squared, then r squared equals 9. So what is r? So what is the value of r? Well, let's take the square root of both sides using that square root property. R would equal plus or minus 3, but radius is a measurement. And is only positive 3. So it's true. 3 is the radius of this equation, x squared plus y squared equals 9. Okay, let's go to the next page then. And let's look at the second example. Okay, let's look at example number 5. Example number 5 says, use the graph to find the center and radius, then write standard form. Use the graph to find the center and radius, then write standard form. Okay, so on the graph, remember HK is the center, and remember R is the radius. Okay, and so based on the graph, where is the center at? Look at that. It's happening at -2, 1. This is your H and your K. Notice that that's like an X and a Y in the points that we talked about in 2.1. And then our radius in this graph is worth 2. Count it. Okay, so then let's apply it. Okay, so our standard form looks like this. So let's just substitute those values in. This is our formula. So then let's substitute the values in. This is going to say what? X minus a -2 squared plus y minus 2 squared. Let's see, I'm sorry, let me undo that. That's not correct. What is our K value? That is actually 1, so y minus 1 squared equals the radius, which is 2 squared. Okay, well, this is minus a minus 2. That's the same as x plus 2 squared plus y minus 1 squared equals to 4. And that would be our final answer. We used information from the graph to get our equation in standard form. And notice with that you were only putting in the left-hand side information. The 4 is already in the box. It's already been written there. Okay, let's look at number 6. Example number 6. Okay. Now, it says find center and radius. And that's based on the graph. Okay, if you look at that graph, you're having to count, and what happens is you're having to add those two x's and y's. So your center is a little bit interesting there. The two x's, if you add those x values together and divide by 2, you're getting an x value, which is actually your h, a 2.5. And then you're getting a y value of 5, which in this case for a circle is the k value. Okay, and your radius is also showing up equal to a decimal value 1.5. Well, probably better convert these to these decimals to a fraction. So let's see how to do that real quick. Let me call up the TI virtual calculator and let's clear this. And with this, we have a 2.5, but I don't want to leave it in decimal form. So go to your math button, which is right under the alpha. Click that. It's number 1 is already highlighted. It's saying convert that to a fraction. Hit your enter. It's saying I'm converting 2.5 to a fraction, and that fraction value Okay, notice that it changed in that point. So now our center point would be written as 5 halves, 5, and then radius. Let's bring that TI-83 calculator back up, and let's convert the other one, the 1.5 for the radius. Change that, go to math. It's already on fraction mode. Enter, enter. And notice that's 3 halves. So our radius in fraction form is now 3 halves. Okay. Alright. Alright, so now let's put this in the right form. That means you've got x minus 5 halves squared plus y minus 5 squared is equal to 3 halves squared. Well, if you're squaring the 3 halves, we had to simplify that. So the final thing would be x minus 5 halves squared plus y minus 5 half squared, and then 3 squared is 9, 2 squared is 4, and this would be your final answer. Okay, let's look at example number 7 now. Example 7. Wants us to write the standard and general form of the equation. Of a circle of radius which equals to 10 and center HK equals to 0, 0. Okay. Alright, so if this is x, this is y, and this is r, x minus, this is the standard form, x minus 0 squared plus y minus 0 squared equals 10 squared, which is 100. Okay, and then general form, well, x minus 0 squared is just x squared, y minus 0 squared would just be plus y squared equals 100, but remember we want this side equal to 0, so subtract the 100 for both sides, and this would be your final answer for the general form of this equation. Okay, and then based on this they want us to actually graph. Okay, and so let's show the graph of this. Okay, so the HK was again 0, 0, right? And the radius was equal to 10. Always pay attention to what your units are saying. A lot of times they'll do it by 2s, it may do it by 1s. I'm going to do it by 2s here. So these are by 2s. This is 2, 4, oops, I'm sorry, 4, 6, 8, 10, and similarly this is -2, -6, -10, and this is 2, 6, 10, -4, -8, -10. Okay, so let's plot this. Our starting point is 0, 0. On your graph it may actually be all by 1, so you would go out to the 10 if that's the case. But if the radius is 10, you're going to go keep pulling out this way until it clicks out here to the 10. And what happens is it actually pulls all the way around, and my graphs are not perfect. Didn't get an A in majoring in art, so but it'll pull it to where if you pull out to the 10, whether it's in 2 units or in units of 1, it's going to pull a whole circle for you. Again, my diagram's not great, but that's what happens. So you plot your center and then pull out with the radius. Okay, let's look at example number 8. Okay, example number 8 also wants us to write standard form, standard, general form, and then they want us to graph. Okay, and this is the information that they gave us. The radius was worth 1, and the HK, the center point, was worth 0, -1. Okay, so here's the standard form. X minus 0 squared plus y minus a minus 1 now changes that to a plus 1 squared equals to 1 squared, which is 1. Okay, that's standard form, which can be condensed to just x squared plus y plus 1 squared equals to 1. Okay, then we want general form. Okay, and so the x squared just stays the same here. When we square this, what does that really mean is happening? You've got y plus 1 times y plus 1. So you're squaring y times y is y squared, outside times outside is 1y, inside times inside is 1y, that combines to be 2y, and then last times last is positive 1 equals 1, but then remember you're subtracting 1 off of both sides there, and so then your general form ends up being x squared plus y squared plus 2y equals to 0. And that's your final answer for the general form. And then they want us to show this graphed. Okay, so once again, let's look at the graph for this. Graph, if you've got a radius of 1 and an HK of 0, -1. Okay, where so where is our center point at? 0, -1 is happening right here. And if our radius is 1, that means we're going 1 away here, and it'll stretch where there's 1 away here, 1 away here, and 1 away here. So this is your circle. Okay. Alright, we've got 2 more examples to do, and this will complete it. Our exercise for today for our samples. Let's go now to example 9. Example 9, once again, is asking us to write standard form, write general form, and then graph. Okay, the information they gave us was the radius is equal to 5 and the HK is worth what? It is worth 3, -4. Okay, alright, so here's our standard form. Okay. We want x minus 3 squared plus y plus 4 squared equals 5 squared, which is 25. Okay, that's your standard form. And from that, we can get our general form. Okay, because we've got x minus 3 times x minus 3, and then we're going to add to it y plus 4 times y plus 4, and then eventually we will subtract the 25 from the right side. So first times first is x squared here. Outside times outside is a -3. Inside is another -3x, so that's going to be a -9x. And last times last is a +9. Plus, first times first here is y squared. Outside times outside will be 4y. Inside is another 4y. This gives us 8y. And then last times last is +16 equals 25. Okay, so let's start to put this in the right form. We'll have x squared listed first, plus y squared, then minus 6x plus 8x plus 25. When we're combining the 9 and the 16 equals 25, but when we subtract this 25, what happens to the 25? It goes away. So then our final general form answer is x squared plus y squared minus 6x plus 8y equals 0. And this is our standard form answer here. Okay, and last thing they want us to do with this is graph it. So we graph using our tools. The radius was 5 again, and what was the center? The HK was 3, -4. Okay, 1, 2, 3, 1, 2, 3, 4. Here's where the center point is, right here. Then we're going to need 1, 2, 3, 4, 5 right there. If you go 5 away and stretch it over to that direction, then And if you think about it and going 5 down for the radius, it would be right there. And if you go 5 up, 2, 3, 4, and then be right here. And once you stretch it to the 5 here, then it will just automatically have created the circle that you see for the whole thing. And my graph's not perfect, but there's where the dots are, and that's what should have connected the circles. Okay, let's do our last problem now. Okay, our final example, example 10. Again, it is still asking us to write standard form, write the general form, and then graph. Okay. Alright, and this is the information it gave us. There was a radius of 10 this time, and then there was a center point HK that's described as -8, -6. Okay, so standard form. We'll have x plus 8, because -8 is a +8 squared, plus, we use a plus with circles because we're adding the two halves together to make a whole circle. Y -6 is a +6, and that's squared, equals 10 squared, which is 100. Okay, that's your standard form answer. And then here's your general form answer. Once again, you're going to square both the x plus 8 and the y plus 6. So that's going to be x plus 8 times x plus 8 plus y plus 6 times y plus 6. And that equals 100. Okay, so this is going to give you x squared, outside times outside, inside times inside, is going to be plus 16x. Last times last is plus 64. Plus, well, first times first is y squared. Outside times the outside, inside times inside will be plus 12y. And last times last is plus 36. And then we're going to subtract the 100, right? So make the right side 0. Well, that leaves you with x squared plus y squared plus 16x plus 12y. And notice that 36 plus 64 minus 100, that's going to zero all of those out. All of these are going to zero out, so then that's all that's left. And this is your general form answer. And then finally we just need to graph it using the information. We're going to graph, again, our radius was 10. They'll probably use twos, count by twos with this one, just to make it easier to graph, so pay attention to that. And then your HK center is equal to the 8, negative 6. Okay, so again, they're going to be counting by 2's. Let's see where this is going to be at. Negative 8, negative 6 is going to be in this quadrant here. Counting by 2, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8. Okay. Again, so this is 2, 4, 6, 8, 10. See how they're counting by 2's? And similarly here, this would be negative 4, negative 8, negative 4, negative 8, negative 4, negative 8. Okay, so where is negative 8, negative 6 at? Let's pick up our point here. It's going to be right here. And again, we're counting by 2, so be careful. The radius is 10, so 2, 4, 6, 8, 10. The next one's here. 2, 4, 6, 8, 10. The next one's right here. And let's go this way. 2, 4, 2, 4, 6, 2, 4, 6, 8, 10. The next one is going to be out here. And 2, 4, 6, 8, 10. Would be down here. Usually when the graphs get really, really big, this is how they handle that. They count by 2's instead of 1's. And then, like I said, by stretching just 2, 4, 6, 8, 10, then it's just automatically going to create that whole circle just like this as you stretch it out to the one place. Okay, again, my graphs are kind of crude. Alright, this concludes your notes and examples for section 2.3. This should be able to help you with your homework assignments.